These shifting shards illustrate a machine's raw experience of information. While we see an equation, the computer perceives a void of disconnected inputs with no inherent relationship to one another. A computer processes the letter A, an equal sign, and a plus symbol as individual numeric codes. Within this vacuum, these characters carry no mathematical weight. They are just data points in a sequence. To bridge this gap, code enters the compiler. This digital assembly line is engineered to extract mathematical order from that flat sequence of characters. The first chamber of this machine handles the pre-processing. Before the computer can apply logic or calculate a result, it has to transform the raw text into a format the system can actually navigate. For a machine to follow a human instruction, it must systematically manufacture structure from these fragments. That manufacturing starts with lexical analysis, or the lexer. Its job is to scan the raw characters and group them into recognizable units called tokens. The lexer follows a narrow set of rules, essentially checking a dictionary. It only asks, is this specific word or symbol a valid part of our language? Consider a flawed line of code like A equals B plus colon. A human programmer immediately sees the error. The plus sign is missing its second operand. The lexer scans the sequence from left to right, identifying A, B, and symbols as valid tokens. Reaching the plus sign, it issues a green checkmark. To the lexer, the plus sign is perfectly valid, regardless of its position. This reveals the limits of the first phase. A sequence of valid vocabulary words does not necessarily form a valid instruction. This is why the code moves to syntax analysis, performed by the parser. The parser ignores individual vocabulary and focuses entirely on grammatical arrangement. Tokens are pulled from their flat sequence into a two-dimensional space to build a hierarchy. The equal sign acts as the root, branching down to A and the addition operation. The plus operator then connects to B and C, completing the parse tree. When we re-examine the broken code, A equals B plus, we can see why the parser succeeds where the lexer failed. The parser attempts to build the tree, but when it reaches the right side of the plus operator, it finds empty space. The branch has nothing to connect to, violating grammar rules and triggering a syntax error. The parser validates the arrangement. Without a confirmed grammatical structure, the machine has no foundation to begin processing the code's actual intent. Once a parse is successful, the resulting tree serves as the blueprint for every subsequent step in the compiler. This leads to semantic analysis. This phase finally checks for context, ensuring variables are declared and the data types are compatible for math. Semantic analysis cannot function on a flat stream of text. It relies on the tree provided by the parser to understand which variables are being acted upon by which operators. This pipeline mirrors the construction of a house. The lexer gathers the bricks. The parser arranges those bricks into structural walls. Only then can semantic analysis begin the inspection phase, checking the functionality of the plumbing and electricity. In computing, meaning depends on structure. Before a machine can perform an action, it must first successfully map the relationship between its inputs.